Good afternoon, class. We are looking at exam one review, and it covers from section 1.6 to 3.1. We have looked at the first half. Here's the second half. We want to find the following limits. Some of the questions come from the lecture, some of them from the exam review that can be found under the modules in Canvas. For example, the limit as x approaches 1 of square root of x plus 3 minus 2 over x minus 1. If you plug in 1, you get 0 over 0. It's an indeterminate form. So it requires an algebraic technique to fix the problem. An algebraic technique involves conjugate. The conjugate of a minus b is a plus b. So the conjugate of the numerator, because it's a square root, that's what you're looking for. You write the same thing and you change the minus 2 to plus 2. You multiply and divide by it. The methodology is that the denominator, you keep it as a product. You don't touch that. Because x is approaching 1, x minus 1 is 0. That's the problem. So you multiply, the top becomes a squared minus b squared. Square root of x plus 3 quantity squared minus 2 squared. 3 and negative 4, they add up to negative 1. And now x minus 1 cancels out the x minus 1. And if we plug in 1, we get square root of 4, which is 2, and 2 is 4. So the final answer is 1 over 4. Questions 26 and 27. X is approaching 6 from the right. Whether 6 is from the right or left, for the numerator is very close to 6 and it makes no difference. For the denominator is very close to 0 in both cases, and it does make a difference because the left side, 0 from the left, gives us a negative value from the right, a positive value. Because of that, we are going to apply that to the denominator. 6 from the right, an example of that would be 6.1 minus 6 is 0.1, and it's 0 from the right. But for the next one, from the left, for example, 5.9 minus 6 results in minus 0.1. So 0 from the left. Both cases give us infinity, but this gives us positive infinity. And since this one, the denominator approaches 0 from the left, negative infinity. The limit of ln, natural log of x squared minus 16 as x approaches 4 from the right. If you plug in 4, you get 0. 4 from the right, that means 0 from the right. And what is natural log of 0 from the right? I hope you remember the graph. As we approach 0 from the right, it creates a vertical asymptote, the y-axis. So the answer is negative infinity simply by remembering the graph. We want to take a limit of this expression. We plug in and we get 0 over 0. Generally speaking, it is the 0 in the denominator that creates a problem. X approaching minus 5, that means there is a factor of x plus 5. The bottom is x squared minus 5 squared, or a squared minus b squared. It's a minus b plus b. You can factor easily. The numerator becomes x times x plus 5. The denominator is x plus 5 times x minus 5. You drop the common factor of x plus 5. And now if you plug in minus 5, the numerator becomes negative 5. The denominator becomes negative 10. The ratio is positive 1/2. The limit of 1/3 minus 1 over x minus 3 as x approaches 3. When we plug in, we get 0 over 0. Because this is a complex fraction, the technique is to multiply the top and the bottom by LCD, which is 3x. So as far as the denominator is concerned, we keep it as a product. As far as the numerator is concerned, we distribute. As we distribute over the numerator, we get x minus 3. They cancel each other. And when we plug in, we get 1 over 9. What's important to know, you have to carry the limit sign, okay? Otherwise, you can't replace the x with 3. What about the limit of the square root of 2x squared plus 16 as x approaches 0? Just plug in. When you plug in, this becomes 0, everybody. So square root of 16, which is 4. So it's pretty straightforward. I hope everybody is okay with that. So the key being plug in first and observe. So we are going to plug in and observe. And if need be, we use our algebraic techniques to fix the problem. We'll do the same thing here. We're going to plug in. I hope you see if you plug in here, the denominator becomes 6 minus 3, which is 3. But if you plug it to the numerator, you get 0. And you're done. 0 over any number is 0, as long as it's not 0 in the denominator. So 0 over 3, and we're done. The limit of the square root of 49 plus h minus 7 over h as h approaches 0. If we plug in, we get 0 over 0. So what is the technique? Remember that whenever you have a square root and you get 0 over 0, you got to multiply by its conjugate. That is the technique we use because the conjugate of a minus b is a plus b. The product is a squared minus b squared. So let's do that. When we multiply by the conjugate of the numerator, we're going to multiply and divide. The reason we do so, because this fraction must be equal to 1. You can't just multiply the top by it or just the bottom by it. You have to do both. Okay. This is extremely important, everybody. So what do we do next? We keep this as a product. We don't distribute because the problem is the h that is approaching 0. But we multiply these two and we get square root of 49 plus h quantity squared minus 7 quantity squared. 49 plus h minus 49, 49 and minus 49 cancel each other. H and H cancel each other. And now if I plug in, I get square root of 49, which is 7, and 7 is 14. So 1 over 14 is the final answer, everybody. The limit of 3x squared plus 11x minus 4 over 2x squared plus 11x plus 12 as x approaches minus. I'm going to leave it for you to show that if you plug in, you get 0 over 0. So the technique is factoring. Now, a couple of things I want to say about the factoring. Number one, this is 3, so it's a prime number, it's 1 times 3. This is 2, it's a prime number, it's 1 times 2. So I'm going to write it as such. Number 2, if you look at x approaching negative 4, that indicates there must be a factor of x plus 4 in the denominator that creates the 0 here. So therefore, x plus 4 must be in common for both of them. So clearly, this is x plus 4, this is x plus 4. And if you divide negative 4 by 4, you get negative 1. If you divide 12 by, you get positive 3. So I hope you see how easy we can factor this out. And you should really check the middle term. Remember, 4 times 3, 12x, minus x is 11x. 4 times 2, 8x, plus 3x is 11x. You want to check the middle term. Now, of course, the common factor of x plus 4 drops. And now you plug in. So minus 4. 3 times that, negative 12 and negative 1, negative 13. Minus 4 times 2, minus 8 and 3, minus 5. The answer is 13 over 5. And that's the final answer. It's, again, pretty straightforward. I hope everybody's okay with this. Factoring is the key. Derivatives and rates of change. Given y equals f of x and point A, comma f of a, this point, the slope of a secant line PQ, you have another point. The blue line is called the secant line. Represents the average rate of change of y with respect to x, and this is a good old slope. M, the slope of a line, is delta y over delta x, rise over run, y sub 2 minus y sub 1 over x sub 2 minus x sub. Or if we go with that, would be f of x minus f of a over x minus a. If we represent it differently, that means this is af of a, and we see the distance of h, that is the run. So this becomes a, this is become a plus h, and this has coordinates a plus h and f of a plus h. So the rise is f of a plus h minus f of a. The run is a plus h minus a, which is just h. If this point, now instead of x, we call it b, then this becomes f of b. So f of b minus f of a over b minus a. The point being, they all represent the good old slope, rise over run, also known as a difference quotient. Now, if we have several secant lines, and we are moving the point Q of the secant line closer and closer to the point P of the secant line to create the red line, which is the tangent line, then the tangent line is defined as the limiting position of the secant line PQ as Q approaches P. A tangent line is a line that touches a curve at a specific point without crossing it. Slope of a tangent line, also known as instantaneous rate of change. We can write it in any of these formats. Take a look. If we want to go with the limit of m of pq, q approaches p. If we want to go with this one, x approaches a. If we want to go with this one, h approaches 0. And we call it slope of a tangent line, or f prime of a. And normally we use these two. Now, if you're interested in finding a equation of a line, there are three formats. Standard form ax plus by equals c. That means x and y are on the same side. We are looking at this point. Y minus y1 is m times x minus x of 1. That's a point slope. And when we solve them, for y becomes slope intercept form. So if you want an equation at this point, a f of a, we're going to go with that y minus y1. That means y minus f of a equals m f prime of a. X minus x of 1, that means x minus a. You can memorize that, or just easily just do the point slope, apply the point slope. It's really that simple. So here's an example. We want to find the equation of a tangent line where the function y or f of x is x squared, the pair x comma y, 1 comma 1. Again, I want to emphasize they don't have to give you the pair. All they have to do is giving you the x. If the x is 1, so is y. If the x is 5, y is 25. If the x is 7, y is 49. So you can calculate it. In this case, a is 1, f of x is x squared. And we are going to use one of those definitions to find m, in this case, f prime of a, is the limit of f of x minus f of a over x minus a as x approaches a. And of course, a is 1. Replace the f of x with x squared, f of 1 with 1. If you plug in, you get 0 over 0. And therefore, we are going to factor. Recall x squared minus 1 squared follows the a squared minus b squared. The top becomes x minus 1, x plus 1. And now if you apply the limit, you get 2, and that's the slope. That's what we really want to find. This one, you don't have to memorize the equation of a tangent line. Just remember the point slope, plug in, y becomes 2x minus 1. We've seen this a number of times. So, for example, this one is 2x minus 2, and this will add a 1. I want to look at the second method for practice. M is the limit of f of a plus h minus f of a over h as h approaches 0, and we replace the a with 1. So what is f of 1 plus h? 1 plus h quantity squared. What is f of 1? Simply 1. 1 plus h squared, we know a plus b squared is a squared plus 2ab plus b squared. So it's 1 plus 2h plus h squared. 1 and negative 1 cancel each other. The numerator, we can factor out the h cancels out. And the limit of 2 plus h as h approaches 0 is 2, just the same as what we found here. Please understand, do not lose the limit sign at the end, because if you don't have the limit sign, 2 plus h is equal to 2 plus h. You can't replace the h with 0. The distance in feet of an object from a starting point is given by this function, where t is time in seconds. What is the average velocity of the object from 2 to 4 seconds? So average velocity is total distance, that means s of t sub 2 minus s of t sub 1, over total time, that means t sub 2 minus t sub 1. So it makes it s of 4 minus s of 2 over 4 minus 2. So the denominator is 2. What is s of 4? Plug in 2 times 4 squared minus 5 times 4 plus 40. What is s of 2? Plug in 2 times 2 squared minus 5 times 2 plus 40. And you simplify this one, you simplify this one, you get 52 minus 38, which is 14 halves, gives you 7 feet per second. This is elementary algebra, everybody. What is the instantaneous velocity at 4 seconds? And by the way, reminding you 2 points in time means average, 1 point in time means instantaneous. Then you can use the definition. V instantaneous is the limit of S of A plus H minus S of A over H as H approaches 0, and you replace the A with 4. Now, all we have to do is simplify the numerator. We have to evaluate this one minus evaluate this one. This one, we don't have to do anything. We already have the answer. S of 4 is 52. S of 4 plus H would be 2 times 4 plus H squared minus 5 times 4 plus H plus 40. 4 plus H squared is A plus B squared is 4 squared or 16. 2 times 4 times H is or 8H plus H squared. Distribute the 2, you get 32 plus 16H plus 2H squared. Distribute the negative 5, we get minus 20 minus 5H, and you keep the other two numbers. Notice all those numbers, 32 minus 20 plus 40 minus 52, they add up to 0. So in the numerator, you have 2H squared, and 16H and minus 5H, they add up to 11H. You can factor the H out. Drop the common factor of H from the numerator and the denominator. And now, if you replace the H with 0, you get 11 feet per second. I can't emphasize this enough. This limit sign remains especially right here, so you can apply the limit by replacing the H with 0. Continuity. G of x is a piecewise defined function equals to 1/2 x plus 3 for x less than -2 and equals x minus 1 for x larger than or equal to -2. Is G of x continuous at x minus 2, why or why not? Reminding you, continuity means the limit of f of x as x approaches a equals f of a. That means the limit and the functional value are identical. Also reminding you, one-sided limit indicates a function has a limit at a if the limit of f of x as x approaches a from the left and right are identical. Why are we looking at 1 point and 1 point only? Because this is a piecewise defined function. Each piece is a linear function and therefore continuous everywhere from negative to positive infinity, which makes the top one continuous from negative infinity to -2, the bottom one continuous from -2 to infinity. We check the endpoint by looking at three things: the functional value and the left and right side limit. So the functional value goes with the equality. This is the piece that is used. You plug in and you get -3. The left side limit, so we're going to look at the less than piece, the top piece. So 1/2 x plus 3, x equals minus 2. The limit of g of x as x approaches -2 from the left. That means 1/2 of x plus 3 evaluated at x equals -2. That gives us -1 and 3 equals 2. For the right side limit, you need the greater than, so you need x minus 1. The limit of g of x as x approaches -2 from the right equals the second piece x minus 1 such that x equals -2. You plug in, you get -3. Clearly, the limit from the left and right are different. Therefore, the limit does not exist. If the limit does not exist, the function is not continuous at x equals -2. However, one may look at it in the following manner. Is g of x continuous, CT is short for continuous, at x equals -2 from the right? It could be continuous one-sided. Nevertheless, it doesn't change the fact that it's discontinuous at x equals -2. So as we look at it, we notice the functional value and the limit from the right, they are identical. Therefore, the answer is Yes. Although the function is not continuous at x equals -2, I can't emphasize this enough. Yet it is continuous at x equals -2 from the right.